Good morning. For all the 40 questions or 39 questions, we will try to first eliminate using the options without even knowing the answer. If we can't, then we will go and try knowledge. Okay. Coming to the first question. Consider the following statements regarding types of orbit. The objects in the geostationary orbit have an orbital speed that matches the Earth's rotation, yielding a consistent position over a single longitude. See, anything which is on a geostationary orbit will be on the equator. Okay, so there is only one latitude and it will be fixed to a single longitude. On the equator, they will fix it to a single longitude, like it will act like a crosshair. It will act like a crosshair and it will be fixed to that position. Say it is focused in Vizag IAS Academy, it will catch the longitude of Vizag IAS Academy and we assume that it is an equator, then it stays there. Okay. So, it is a fixed position with respect to a single longitude and on the equator. The longitude can be anything. Okay. Now, the objects in the geosynchronous orbit only orbit the Earth's equator. No. Any angle. So, geosynchronous is a superset of geostationary. Okay. Geostationary is a subset of geosynchronous. Geosynchronous orbit can have an eccentricity and also can have a angular tilt. Okay. Eccentricity means it can be it need not be circular. It can be an elliptical orbit. Okay. It can also be tilted to with respect to the equator, it can be tilted with an angle. Okay. So, coming to geostationary, it is not like that, it is on the equatorial plane and it is a circular plane. Okay. Now, there can be other questions on these two areas. So, what can be the other questions? There can be a question on application. What are the he can give you different satellites and he can ask you which satellite is in which orbit based on the applications. Okay. So, where is synchronous used and where is geostationary used? Communication satellites, which where there is a fixed antenna, they will be locked to a particular satellite. So, they cannot move frequently. Those will use geostationary. Okay. Geosynchronous, they trace a path like number 8, but at the same time, at a particular point of time, they will be on that place. Okay. Next, consider the following pairs: orbit and the purpose. First one is low Earth orbit. It is orbit used for the International Space Station. Right. Low Earth orbit has other purposes also, and one of that being ISS. ISS is placed at low Earth orbit, one because it is easy to access. The travel time will be far lesser if it is in the low Earth orbit. Okay. Then sun synchronous orbit. The satellite in this orbit will always observe a point on that as if constantly at the same time of the day to investigate how weather patterns emerge. Sun synchronous. Sun synchronous is a variant of polar orbit. Okay. Polar orbit is when a satellite circulates along the poles up to 30 degrees. It can be a tilt up to 30 degrees, but if it is between two poles, it is rotating between two poles, it is called polar orbit. But if a satellite which is in polar orbit is in sync with the sun, say little ahead of the sun, so that it always has light on wherever it is focusing. Okay. If it is in sync with sun, whatever sun illuminates, it will capture. Okay. That way it will not have the headaches of darkness and night and all. Okay. So, at single point of time, at a particular point of time on a particular day, it will be capturing that from a particular point. Okay. And in sync with the sun. So, it can be used for forestry. Say for example, how much afforestation is done or deforestation is done. It will be taking years pictures. Okay. Every day it will be taking a picture. So, it can give you the resource levels at the bottom. Okay. on the earth, and there are a number of things, weather patterns, for example, how cloud movements are happening any particular time at a particular location. All these things can be useful, can be used for sun synchronous orbit. Next, highly elliptical orbit. The satellites in highly elliptical orbit are suited for communication, satellite radio and remote sensing. What is highly elliptical orbit? See, each orbit, see the options given here, these are not just limited to, we cannot limit to just these, okay. There are couple of other applications to each orbit, okay. For high elliptical orbit, he said that it is suited for communication, satellite radio and remote sensing, which is true, but why can be another question. Why high HEO is suitable for something and in which areas? HEO is suited for higher latitudes. Normally the mid latitudes can go with geostationary orbits, okay. But for higher latitudes, geostationary orbits will be little above origin, okay. So it will not be very useful. So what they do is they have an elliptical orbit with the larger pathway towards the poles. So it will be like this. So what happens is, it can dwell a lot of time on the north or the south part of the earth, the higher latitudes. Thereby, see the time period 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and here it is only 1 hour. Okay, this highly elliptical orbit dwells a lot of time on the upper latitudes, higher latitudes, thereby capturing lots of data about the higher latitudes. So if you want to capture anything about the Arctic, the Siberian and any other higher latitude areas, about their climate, about their weather patterns, everything, they can use elliptical orbit. So coming back, what is the answer? 1 is true, sun synchronous true, B is the answer, okay. Now there are so many other orbits, not just geosynchronous, geostationary or elliptical orbits. There are a couple of other orbits. You have to know them very clearly, okay. What kinds of questions can be asked? One, their elevation, at what height they operate. Is it a low earth orbit, middle earth orbit or high earth orbit, okay. And then is it eccentric or is it just circular, okay. Eccentric, we have just seen highly elliptical orbit, okay, it's highly eccentric orbit, okay. Similarly the purpose, okay, for what purpose do they use? Do they use for resource mapping or communication or navigation, okay. So there are a number of such possible questions on each of these orbits, okay. So geostationary we have discussed very clearly, okay. Geostationary, it will be on the equator. The advantage is antennas get locked, I mean the receivers get locked to a fixed location, so it is very good for communication, okay. But it has a disadvantage, it cannot contribute to higher latitudes. So there we go for some other orbits like higher elliptical orbits, okay. Now geosynchronous, it is more or less similar to geostationary, but the eccentricity and the angle of tilt, okay, there can be little angle of tilt, but the height is same. Both are at around 36,000 kilometers. At around 36,000 kilometers, 35,000 odd, you can say, okay. So geostationary is a subset of geosynchronous. Next is low earth orbit. Anything as low as ISS, okay, International Space Station, to up to 2,000 kilometers is considered as low earth orbit. Low earth orbit has a significant advantage because one, the fuel needed to put a satellite there is very less. I mean the costs are very less to put a satellite there, and if you use enough number of satellites, okay, you can cover the whole earth, but the vantage point is less, okay. What a geostationary satellite can see and what a satellite in low earth orbit can see vary, okay. If you can use 3 geostationary satellites and cover the whole earth, okay, but same thing cannot be said about low earth orbits. So that is a disadvantage. So what it can be used for, low earth orbit? If you want to take pictures, you should be as close as possible, okay. Anything that wants to observe the earth, okay, it is good to be put on low earth orbit, okay. Then medium earth. Medium earth is anywhere between the 2000 km and the 36,000 km. Okay. Geosynchronous, geostationary and 2000 km. Anything between this is medium earth orbit. What is it used for, medium earth orbit? Navigation. GPS, GLaNOS, okay, our Navic, Beidou, okay, all these things and more, okay, more are coming. All these are in middle earth orbit. Okay, there can be a match the following question there also. Next, polar orbit and sun synchronous orbit. We have already discussed this. Polar orbit, anything that revolves around the poles with a tilt. It can be 30 minus and 30 plus. Okay, it is called polar orbit. Sun synchronous, anything that is in sync with the sun, so that wherever it points is illuminated. Okay, so that is sun synchronous. Highly elliptical orbit we have discussed. Next, transfer orbits and geostationary transfer orbit. You know, we have discussed that the geostationary orbit is 36,000 km above the Earth's surface. So it takes lot of fuel for us to go there. Okay, so what they do as a tweak, what they do is they keep the satellite in a low Earth orbit or a middle Earth orbit. Okay, and slowly start the boosters in the when it takes curves and it enters the geostationary orbit. Okay, it will take lot less energy and lot less cost. So that is called a geostationary transfer orbit. Next comes Lagrange points. There is a question we will discuss in detail. Lagrange points are sometimes called as parking lots of space. Okay, parking lots of space where you can park your satellite and be assured that there will be minimal disturbance in their path. Okay, so we will discuss this later, but these are the possible question areas. Each one, their applications, their height, their altitude, everything can be question area. So you should be very thorough with these areas. See some of the applications. Have a look at some of the applications. Most of our satellite, Hubble. Third one, which of the following are objectives of the Reusable Launch Vehicle Technology Demonstrator, RLVTD. See, there are couple of technology demonstration missions being launched by ISRO. Okay, one of that is RLVTD. The other one is what else? Yeah, there are 3-4 missions. Okay, one mentioned by Jitu, SSLV. SSLV is also it's still under demonstrator this thing. Okay, so one of such mission is RLVTD. So the options here. See, this one is a very static question. These are mission. See, every mission has a particular agenda, objectives. Okay, so these are the objectives given in the mission data. Okay, so these are all true, 1, 2, 3 and 4, D. So what is the Reusable Launch Vehicle Technology Demonstrator? What is reusable launch vehicle? See, reusable launch vehicle space travel is very costly. Okay, if you can reuse any of the components, okay, may it be boosters, okay, or the higher part of anything that can be reused will reduce the cost. Okay, so they are trying to starting from with SpaceX, many other companies, even NASA, ISRO, so many people are trying to reuse various parts of the launch vehicle. Okay, so in that kind of endeavor, we try to use couple of components. Okay, so this is our version of reusable launch vehicle. So this is a successful test actually. What they did is you can see something which is coming out. This is the booster. This is the booster which is falling down into the ocean, the sea. Booster also can be reused. Okay, and the actual vehicle, winged vehicle. Okay, unlike rocket, this is a winged vehicle. Even that can be reused, provided there is some rejig done. Okay, they successfully tested it. So there are 3 things here. One, they tried to test hypersonic flight, not subsonic, not supersonic, hypersonic flight, autonomous landing. It has to land by itself in a predestined location. Okay, and power cruise flight. Okay, cruise flight. Okay. So all these three things they have tested thoroughly. So they are trying to reuse it for the other missions, future missions. Next question. Consider the following statements. Which are the satellites given above Earth observation satellites of ISRO? See, this you can eliminate directly, because looking at IRNS-11, IRNSS-1A, you can you know that it's a navigation satellite. Okay. So once you remove 3, you get the answer. Okay. So the answer is C, 1, 2 and 4. So here he is asking about Earth observation satellites. Okay. According to latest data of ISRO, we have currently 13 operational satellites in sun synchronous orbit, and we have 4 geostationary satellites in geostationary orbit. These are all remote sensing satellites. Okay. Next, consider the following statements regarding cryogenic rockets. The cryogenic stage is a very complex system due to its use of propellants at extremely high temperatures. No, extremely low temperatures. The propellants used by cryogenic system are liquid oxygen and liquid hydrogen. True. So the answer is B, 2 only. So what is a cryogenic engine? What is the purpose of cryogenic engine? Why shouldn't we use other, see, we already use solid and liquid fuels, right? Yeah, for a gram of cryo fuel consumed, you get more thrust when compared to other solid or liquid propellants. Okay. So that is the main advantage. That is because highly calorific value. Hydrogen has a high calorific value. It is condensed into a liquid form, and the oxidizer, which is oxygen, is also in the liquid form. They are combined and pumped at a very low temperatures. Okay, in the liquid forms. So it gives a great thrust to the rocket. Okay. More thrust for every kilogram of propellant. That is the main advantage of this one. And the oxygen here, it is at minus 183 degrees centigrade, and hydrogen is at minus 253 degrees centigrade. These are also possible question areas, both these temperatures. Okay. And where is it using? ISRO, where is it using cryo engine? Is it using in PSLV or GSLV is also a question area. Okay. In which future missions it is using a cryo stage is also a question area. Okay. You should be careful with that also. Next, consider the following pairs. Which are the pairs above are matched? See, these are famous missions. Perseverance is by NASA, Tianwen, China, Hope, United Arab Emirates, Insight is NASA. So, how many are correctly matched? Is it incorrectly? Okay, incorrectly matched. 1, 2 and 3. B is the answer. Consider the following statements regarding space debris. It can refer to big or small objects such as dead satellites that have failed or been left in orbit at the end of their mission. It is not just dead satellites, it can also be paint particles, anything that obstructs or something which is not required there is termed as space debris. Okay. Shijan 21 is an experimental space debris mitigation mission of Japanese Aerospace Exploration Agency. No, it is a China's mission. Okay, it is a Chinese mission of trying to reduce the hindrance of space debris. Okay, this mission actually they use another satellite to taxi the used satellite to a higher orbit. Okay, geostationary orbit. See, anything which is in low Earth orbit, over time it can get de-energized, enter the atmosphere, and burn out or fall into the sea. That can be done. Point Nemo is there. We have discussed that. It can be thrown there. Okay, but anything which is in geostationary or geosynchronous, that is around 36,000 km higher. Okay, so we cannot bring it down. All that we can do is change its orbit by 300 km. So it is put around 300 km above geostationary and geosynchronous, so that it is not a hindrance to other orbits. China did that experiment. Okay, and it succeeded. This is Shijan 21. So the answer is One only? One only is the answer. Next, point Nemo is sometimes seen in news. See, this is the simulation of the debris which is found there in space now. You can clearly see two patterns. One is a low Earth pattern, and another is geostationary pattern. Okay, so you can see the two patterns there. Okay, there is a term called Kessler effect. There can be a prelims question like this. Kessler effect or Kessler syndrome is related to which phenomena? It is actually related to space debris, a point beyond which an orbit cannot be used because of repeated collisions. Okay, that is called Kessler effect. Okay. The next question, point Nemo, sometimes seen in news. It is associated to which of the following purpose? Since the question paper is about space, you can guess. I think it is space symmetry, but otherwise space point Nemo is a uninhabitable area where there is no life form or anything and it is situated in South Pacific Ocean. The speciality is it is equidistant from all the coastlines. Okay, it's thousands of kilometers away from all the possible coastlines, and I'll show you the image, you will get it better. So it's in the Southern Pacific Ocean. Every point is equidistant and far away from. It's kind of no man land. There are no center of a gyre. Okay, there is no life there, no oxygen supply, nothing. Okay, so they use it as a graveyard for throwing away used space articles. Okay, whatever it be there. Okay. So it's a point in South Pacific Ocean, uninhabited area. Okay, this is the point where they are going to, retire International Space Station in the future. Once its life is done, they are going to de-energize it and park it there. It has been used by Salute and Mir also. Mir is there can be another question actually. ISS, Mir, they can give you a set of different space stations. They can ask you to match the following with the countries. Mir is of Russia, ISS is combination. There are 5 countries. Okay, there is another one coming. Okay, China's. So all these things can be another question area. Okay. Next, consider the following statement with respect to Lagrange points, which is recently seen in news. See, when we were discussing orbits, the last one is Lagrange points. We have discussed Lagrange points. This is the question on that. At Lagrange points, the gravitational pull of two large masses precisely equals the centripetal force required for a small object to move with them, which is true. Okay, for anything to move around a particular object, you need gravitational force, which becomes a centripetal force. Okay, there they balance out and provide the net centripetal force to rotate with the two bodies. Okay. Next, Lagrange points in space can be used by spacecraft to reduce fuel consumption. Yes, see, any spacecraft in any orbit get de-energized over time. It loses its orbit. So you have to constantly use the thrusters, onboard thrusters, and correct the path so that it's always in, especially low Earth orbits. Okay, because of the gravitational pull. Okay. Here in this case, since it's a point where there is an equilibrium between gravitational forces, it stays put. Okay, or it moves a little based on the Lagrange point. We will discuss that later, which are stable and which are unstable Lagrange points. Next, James Webb telescope will orbit the sun 1,000,000 miles away from Earth at the third Lagrange point. It is at the L2. There is a logic for this. You need not remember the points, you need not by heart which is at which. There is logic for that, we will discuss. See, there are 5 Lagrange points. This is the sun, this is the Earth. Lagrange points are not limited to sun and Earth only. They also exist for any two large bodies. There is a fixed ratio between the two body weight of the two large bodies. If it's satisfied, there will be Lagrange points for those two heavenly bodies. Okay, and the body which is at the Lagrange point, it should be of a minimal weight when compared to these two heavenly bodies. Okay. If it is a moon-sized body, it won't work. If it's a celestial-sized body, it won't work. It should be a very minimal sized body, like a satellite, small satellite. Only then it will be useful. Lagrange point will be useful. So these are the two main points. Then there are actually 5 Lagrange points for Earth and Sun system. Similarly, there are 5 Lagrange points between Sun and Moon. Similarly, there are 5 Lagrange points between Jupiter and Sun. Similarly, for every two bodies, there will be Lagrange points. Okay. Here in this, we'll move on to the next slide. You will understand better. See, these are force contours. Okay, this is how the force is acting. The center one is the Sun. The one you see in the white color is Sun, and this is the Earth. These 2 points, these 3 points are in line. L3, L1 and L2 are in line. If you see, they appear to be on top of a cliff. On top of a cliff, there is a small area which is flat. Okay, they are there, so they are stable and they are not falling this way or that way of the cliff. Okay, gravitation in in the sense talked by Einstein, it actually creates a kind of depression in space-time curve. Okay, this is something like that. Okay, so anything that moves a bit like this will go towards Sun. It will slowly orbit towards Sun and get near to the Sun, and anything that moves a bit this way will slowly come near to the Earth. Similar is the case with this. Okay, it will go either towards the Sun, or if it goes this way, it goes out of the solar system. Okay, now this is least useful for humans. Okay, this is always behind the Sun and it's never visible to us, and it's very far away from us. Whenever you read it, is always here, so it's mostly useless for us. Okay, but this L1 and L2 are quite useful. Okay, L1 gives you the advantage of watching Sun without interference from Moon or Earth or anything. There will be no interference. So anything that is gazing at the Sun or observing the Sun, solar flares, etc., is placed there in the L1. Okay. L2, anything that you are looking beyond. Okay, anything beyond Earth, you place it in the L2. Now L1, L2, L3 are called unstable Lagrange points. Okay, they are unstable because even a minimal movement towards this way or this way will lead to very fast deterioration of orbit. Okay, they will fall steeply towards either Sun or Earth. So they are called unstable. So there needs to be little correction now and then, so that they are fixed at the Lagrange point. But such headache is not there for L4 and L5. L4 and L5 are kind of, in a geographic sense, they are on plateaus. Okay, so they actually self-correct due to Coriolis force also. Okay, it's a much deeper concept, don't worry about it. But since they are in this plane and they are rotating, in little movement will be corrected by the Coriolis component also. Okay, so it's a self-correcting Lagrange points, L4 and L5. Okay, and much more stable, and they are also called as Trojan zones. Okay, Jupiter's moons, a couple of other things, they all get gathered there, L4 and L5. Okay, and anything you want to be there forever, for some time, you can park it there. Okay, so this is the overall L4 and L5 in the simpler terms. If you go deeper, it will be a complex concept. So from this understanding, you can eliminate actually. James Webb Telescope will orbit the Sun 1,000,000 miles away from Earth at the 3rd Lagrange point. Definitely not, we are not using that. We cannot use it also. Okay. So the answer here is A, 1 and 2. Okay. Next, this is a current affairs based question. ChatGPT, Chat Generative Pre-trained Transformer, is a chatbot developed by OpenAI and launched in November 2022. Yes, it was hyped a lot, you all know that. OpenAI is an American artificial intelligence research laboratory consisting of non-profit OpenAI Incorporated. Microsoft also has a stake in this, so yeah, true. Conducts AI research with the declared intention of promoting and developing a friendly AI. Yes. So 1, 2 and 3. It's a straight question from current affairs. Next, scramjet. Just read the question. Consider the following statements in respect of the scramjet engine and sounding rockets. Okay, it's about two concepts, scramjet and sounding rockets. Scramjet engine efficiently operates at hypersonic speeds and allows supersonic combustion. Yes, scramjet, SC in scramjet stands for supersonic combustion, SC. Supersonic combustion ramjet is scramjet. So here the first option is true. Sounding rockets developed by ISRO are 1 or 2 stage gas propellant rockets used for probing upper atmospheric regions and for space research. Is it true? Why not? It's solid. Okay. Next, Brahmos is a ramjet supersonic cruise missile which is capable of being launched from land, sea and air. Brahmos has a ramjet phase. The second stage is ramjet. Initial stage gives the thrust required to start the ramjet. Okay. Ramjet, we'll discuss ramjet, the tech part. So yeah, that is true. So what is the answer? 1 and 3. 1 and 3 is the answer. See, the latest development, even ISRO is working on scramjet engines. It is still in the, still working on them. It's yet to be final. But it's an emerging technology. Very few nations have that. Jet engines, if you know jet engines over time have evolved into ramjet and then to scramjet. Okay. In jet engines, what you have is, see, the first one is turbojet. First one here which you see is turbojet. This is the jet engine. This is the, here you have the inlet, here you have the exhaust. Okay. You get the thrust required to fly from the exhaust gases. Exit minus inlet. What is the velocity at which the gas enters and what is the velocity at which the gas exits? The difference will give you the impulse to fly. Okay. That is how it operates. Okay. In the turbojet, what they do is there will be fans here which suck air, required air for combustion, and then there is a compressor here, okay, which will compress. It will compress the gas to be used. It will compress so that it is hot and it is in high pressure. That's when the fuel is injected and there is a combustion. Okay. Then there can be a fuel, there can be a spark or there cannot be a spark. Okay. It depends on the temperature and pressure of the gas. If there are sufficiently high pressure and high temperature, you need not have a spark plug. Okay. So that's how it operates. And then the combusted gas mixture is ejected and that gives us thrust. Okay. This is the age-old gas turbine. Okay. Turbojet. But the headache with this is it has many movable parts. Okay. The compressor, the fan, everything is lot of movable parts, and whenever you have lots of movable parts, there is high chances of failure. And costs are high. The design is costly. Everything is headache. Okay. And the speeds possible are also not very high. Okay. It's within subsonic and little above Mach. Okay. So they then came up with ramjet. In the ramjet they did away with all the movable parts. Fan, this is a compressor, this is a, they did away with all this, and they used the entry, okay, the path of entry to compress the gas. Okay. So this will work only when this part is moving at higher Mach levels. Okay. At a normal speed, this cannot be used to compress air. Okay. The movement of the aircraft cannot be used to compress the oxidizer. Okay. So the flight should already be moving at a very high speed for this engine to work. Okay. So it alone cannot become your thruster. It alone cannot operate. We were discussing about Brahmos. So in the Brahmos, it is in the second stage, not in the first stage. The first stage, the required velocity to operate this concept, so that the air which enters will be, see, when you are facing the air pressure which you feel on your face depends on your speed. Okay, as and when your speed increases, the air pressure and air speed also increases. So as and when you touch Mach 3, the air that enters is also Mach 3. Okay, at that high speed only these engines work. Okay, at Mach 3 they enter, and then due to the velocity and all, it gets pressurized. Okay, that velocity is converted into pressure, high pressure. Okay, so this high pressured gas is then ignited. Okay, but the difference between a ramjet and scramjet is the ramjet engine has no capability to handle high Mach. I mean, it has to reduce the speed of the inlet gas to a subsonic speed for it to operate the combustion. Okay, that headache is taken off with scramjet. Scramjet, the combustion also can take place at higher Mach levels. Okay, that way they are able to give even higher speeds. Okay, so that is the advantage with scramjet. Okay, this is a very basic understanding. Don't go deeper. This is enough for UPSC. Okay, then Amazonia. The 12th question. Amazonia 1 is the first dedicated commercial mission of New Space India Limited, NSIL. See, recently we know about Antrix. Okay, Antrix was there for some time, but recently they have started two more bodies. Okay, on top of ISRO or associated with ISRO for commercial exploitation or commercial usage of ISRO. Okay, such bodies are NSIL, and there is another body. Okay, so this is question on that. Okay, Amazonia 1 is the first dedicated commercial mission of NSIL. It is true. Once NSIL is formed, this is the first mission. It is in current affairs. Next, Antrix Corporation and New Space Limited, India Limited, are under the administrative control of Department of Space. This you should be able to mark. Anything to do with ISRO, etc., comes under Department of Space. Okay. Next, since its inception, ISRO has launched the highest number of foreign satellites compared to Indian origin. This also you should be able to mark very easily as true, because recently in news, how many did 100 plus satellites India has launched in one go? How many are Indian in that? Okay, so if you take the total tenure of ISRO, operational tenure, the majority of them are foreign satellites. Okay, so the answer is 1, 2 and 3. Now coming to, see, there can be a question on in-space versus NSIL versus Antrix. This is a very possible area, the governance things, what takes care of what. Okay, because all these are recent bodies. So Indian National Space Promotion Authorization Center, that is in-space, supposed to be facilitator and also a regulator. It will act as an interface between ISRO and private parties, and assess how best to utilize India's space resources and increase space-based resources activities. So that is the role of InSpace. It is actually second organization created recently. There is another one that was created in last 2 years, that is NSIL, New Space India Limited. It was announced in the 2019 budget. Okay, it is the marketing arm of ISRO. Its prime focus is, because there is Antrix also, you may get confused what is the difference between Antrix and NSIL. NSIL actually looks into capacity building of local industry for space manufacturing. So local ecosystem, there is too much dependency on ISRO. Okay, we don't have a SpaceX, or we don't have some other a number of companies which are coming up in US and all. We are trying to create similar ecosystem here, so that there is less dependency on ISRO and the total ecosystem exists in private players also. Okay, so NSIL takes care of that. Antrix will handle ISRO's commercial deals for satellites and launch vehicles with foreign customers. Okay, so this is how these three differ in their governance and their roles. And 3 of them come under Department of Space. Yeah, see this GSLV, PSLV, SSLV, all these are very frequently asked areas, and you need to clearly know what is the distinction between a PSLV, a GSLV, and within GSLV there are several subtypes now. Within PSLV also there are different, I mean there is no fixed configuration, depending on the flight objectives they change the number of stages and all. Okay. So these things you have to be very clear. And coming to the latest one, SSLV, okay, all these things you have to know very clearly. Now coming to GSLV, the first option, GSLV Mark III uses the most powerful cryogenic engine developed by India. True. PSLV uses India's first indigenous cryogenic engine. PSLV it normally launches satellites to a lower Earth orbit, so it doesn't need so high thrust which requires a cryogenic engine. So doesn't use a cryogenic engine. Okay, it only uses a, what does it use? PSLV? Solid liquid, solid liquid. Okay, that is the 4-stage solid liquid, solid liquid. Okay. Next, SSLV uses both solid and liquid propellants. SSLV is specially being, see, if you are using Innova for transporting one guy, okay, it is not a very efficient way of using your vehicle. Okay, so what they are doing, when you want to transport small satellites and all, they want to economize. So they are now going for a smaller launch vehicles, small satellite launch vehicles, so that there is efficiency and lower cost and ease. Okay, so SSLV's main purpose is that. Okay, so what is the answer here? 1 and 3. So answer is A. Have a look at. See, these are the launchers under use. This I have picked from ISRO's site. Okay, these are the present launchers under usage. Okay, PSLV, GSLV, LVM3. LVM3 is nothing but GSLV Mark III. They are renamed it as LVM3. Okay. Then sounding rockets. We have discussed a question on sounding rockets. What is sounding actually? I forgot to mention. Sounding actually in first terms it means measuring. Sounding rockets are actually in the initial phase used to measure atmospheric variables. Okay. And also they checked whether particular functionality is working properly or not before the actual launch or before actually using it in a big launch. They used to use sounding missions to test the equipment also. Now coming to launches under development. Human rated launch vehicle, HRLV. HRLV is nothing but a GSLV Mark III, but for human occupation. Okay, so that they can safely take humans and bring them back. Okay, so that is HRLV. Next is SSLV, we have discussed. Next, reusable launch vehicle, RLV-TD, technology demonstrator, means it's still under process. So that also we have discussed. Next, scramjet engine, technology demonstrator, that also we have discussed, that's still under pipelines. Now launchers which have been retired are SLV3 and ASLV. Okay. So why I am sharing this pic is you have to be thorough with each of them. There can be questions and comparison between any two. Okay. Especially the launches under development can be question areas for the coming prelims because they are all new and emerging. You can observe this phenomena. Anything which is old, anything which has been there for some time, he can ask you deeper questions. I mean complex questions. UPSC can ask complex questions. Anything that is new, say for launches under development, etc., the questions will not be so deep. Okay, they can be questions peripheral. Okay, on the top level, it may not go deeper because they are new in use. Okay. Moving on. 14th. Consider the following statements about satellite-based internet systems. Satellite internet constellations like Starlink provide lesser latency than fiber optic internet. What is latency? You click on something and wait for it to load, right? Sir, suppose a website, you click on something and it is loading slowly, bit by bit. Then it's having a very high latency. You click and it loads immediately. It's a website with less latency. Similar is the case with anything, any bandwidth. Okay. So when compared to optical fiber net, all this satellite-based internet, they are having higher latency because it has to signal has to go back to the satellite and come back. So that takes time. So it has a higher latency. So this is wrong. Internet services provided by satellite constellations could be affected by moisture and precipitation. True. It encounters clouds. Okay. It will be affected. Okay. Responsible Space is an initiative by Starlink to outline the approaches to promote sustainability and safe operation of satellite systems in space. Yes, this initiative, everything is right, but the name Starlink is wrong. What is it? OneWeb. So answer is 2 only. OneWeb, you know, because Airtel also acquired a stake, 30% odd stake in that. Now, the next question is about IRNSS. IRNSS rechristened as NAVIC. Okay. Consider the following statements about navigation systems. IRNSS is a global navigation system developed indigenously in India. Everything is okay, but except for the word global. IRNSS is regional. We don't have global. Gagan is a satellite-based augmentation system, SBAS, launched in India to ensure safety of civil aviation by augmenting the IRNSS signal quality. They augment the signal quality of GPS, not IRNSS signal. Okay, so this is also wrong option. 3. Ionosphere layer of atmosphere can interfere with radio communication. This is a NCERT option. You know, ionosphere hinders. So the answer is, so A, 1 and 2 only. So IRNSS, I thought I'll give you a brief about IRNSS. It's a constellation of how many? Count? 7. There is a backup satellite there up in the air, and they one at the ground ready to replace and all, but they actually operate on 7 satellites. Okay. 2 will be in a geostationary orbit. 3 will be in the geostationary orbit, and 4 will be in a geosynchronous orbit. Okay, geostationary, which will be focused on the equator and in and around east and west of India. Okay. The other 4 will be north and south. Okay. So there was a question on NAVIC. They went deeper. They asked from the India's boundary how many kilometers will be covered by NAVIC. Okay. So all these things are important. And is it only for civilian purpose, or is it used for army? I mean armed forces also. Okay. And so these kind of variants are also there. Questions. So you have to go deeper and see. This image gives you all the info, required info. You have a look at it later. Okay. Next, consider the following statements regarding International Liquid Mirror Telescope. See, this is in news. Okay, this is in news. So this question is given. First one, ILTM is a space telescope. ILTM is a space telescope placed at Lagrange Point 2, which is 1.5 million kilometers away from Earth. No. Okay. It is actually where? It's on the ground. Okay. It's in Nainital, Uttarakhand. Nainital, Uttarakhand, and in the Himalayas. Okay. So it is not in the space. So it's a wrong option. Next, in ILTM, mercury is used as a reflective liquid, which is protected from wind by a thin transparent film of mylar. True. Mercury is used, highly reflective. So it is used. Next, they cannot be turned and pointed in any direction. Yes, they cannot be turned and pointed to any direction. They have to be fixed in one direction. They can never be moved again. I will show you why. Okay. So the answer here is 2 and 3. C. C is the answer. So, this is how a liquid mirror telescope appears. See, this is where the mercury is pulled. This disc will be moving at a high speed, okay, so that a parabolic mirror kind of thing is created using the liquid mercury. Okay. This captures the light coming from undisturbed light coming from and reflects it here, which can be observed. Okay. This is simple. Okay. Instead of a glass, you are using a highly reflective mercury, and this is it covers a large area. Okay. Disadvantage with this is you cannot move it. It can just watch the area right above it. Okay. Got it? IT. See, this is not a new thing. Okay. IPv4, IPv6 has been in use for some time, but not many have moved to IPv6. Legacy systems are still in IPv4. So, there are people still who are moving into IPv6 even now. So, it stays relevant even now. Okay. So, consider the following statements with reference to IPv6, Internet Protocol version 6. There are 32 bits in IPv6 address compared to 16 bits in IPv4. 128 bits. Okay. Internet Protocol security is part of IPv6, which provides end-to-end security. Yes. IPv6, there is no option. IPv6 comes with IPsec. Okay. It provides an enabling platform, the Internet of Things and 5G technology. Not only Internet of Things, 5G technology, edge computing, anything that is new and that needs any new hi-fi tech, it will operate on IPv6. Okay, mark it like that if you have that in the question. Okay, so the answer here is 2 and 3, C. So more about IPv4, IPv6 comparison. IPv4 is 32 bit, IPv6 is 128 bit. This numeric, this is hexadecimal, means you alphanumeric. Okay, so you will have numbers, you also have alphabets, everything. Okay. The possible addresses are 4.3 billion, here near unlimited, 7.9 into 10 to the power 28. Okay. So, you need not reuse a particular IP address by masking it. You mask an IP address and reuse it. Okay. That is not required if you use IPv6. Every device can have a new IP. Okay. Okay. There are other couple of, these are the major differences. There are a couple of other this thing, you go and dig deeper. Okay. Next, 18th. Consider the following statements with reference to electromagnetic aircraft launch system. Catobar is one of the efficient methods of launching aircraft under short deck length. Yes, Catobar, kind of catapults aircraft. Normally, aircrafts, jet aircrafts need a runway, longer runway, so that they get the ideal velocity to take off. Okay, they reach the ideal velocity to take off. So, since on aircraft carriers you do not have enough length, what they do is they catapult. Okay, they throw them with a force so that they have that initial velocity. Okay, so that is the use of Catobar. Okay. The Nimitz class of the United States of America uses Catobar. Yes, that is true. Both INS Vikrant and INS Vikramaditya are Catobar equipped carriers. No, Stobar. Both are Stobar. India does not have Catobar. Okay. India planned for INS Vikrant to be Catobar, but we settled for Stobar. Okay. So, this is about this can be a probable area because aircraft carriers and nuclear submarines are all in use. So, I think we did not have a question on nuclear submarines this paper, but you have to be thorough with that also. Okay, because it is in use. Okay, and the related tech also. Okay. So, next one, consider the following statements with reference to in-flight Wi-Fi. Only satellite based Wi-Fi systems can be used in in-flight Wi-Fi. No, they actually have two receivers, one on top and another on the bottom of the aircraft. Whenever they are at the lower altitude, they get the signals from the towers at the ground, okay. And when they are at a distance far away from, unreachable from ground towers, they will take the signal from the satellites, okay. In-flight Wi-Fi cannot be operational if the aircraft is operating at more than 20,000 feet. No, up to 40,000 feet, even more. So, it's a wrong option. Next, the central government has prohibited airlines operating in India to provide in-flight Wi-Fi service to passengers. Why will they? So, no, that is a wrong option. So, what is the option? Not correct, 1, 2, 3, okay, D. See, this is a pictorial representation, you can have a look at later, okay. Next one, consider the following pairs. How many pairs given above correctly matched? See, UPSC starting last year has gone to, gone with this type of questions, asking you pairs, okay. So, you cannot eliminate, you have to take reasonable risk, okay. Dhanush, Prahar, Shaurya, Rudram. Which is the answer? Dhanush, Indian short-range ship-launched ballistic missile. See, you may not get such a very specific question, okay. Given that we have very few portions for the exam, we had to go deeper because we have to give more questions. But UPSC, unless it wants to trouble you too much, it won't go into this deep, okay. So, Dhanush and Prahar and Rudram, I think they are okay. But Shaurya, it's a ballistic missile, not a cruise missile. Ballistic and cruise missile, the differences we'll discuss. There is another question, okay. So, the answer is C, 3 pairs. Shaurya, it's a ballistic missile. Say, I am giving you detailed explanation, you can have a look at later, because there is no much concept here, I am not explaining, it's pure data, okay. Next one, consider the following statements with reference to the 5G technology. See, 5G is also probable area, 5G is in news for some time, so now you can expect a question, a tougher question, not a peripheral simple question, okay. There can be deeper questions, okay. It mainly works in the low, mid and high frequency spectrum. Yes, there are 3 spectrums, low, mid and high, it is true. While 4G provided less than 1 millisecond latency, 5G provides less than 0.1 milliseconds latency. You have to into 10 for this, okay. So, 4G is 10 milliseconds, 5G is 1 milliseconds, okay. So, this is wrong option. Millimeter wave spectrum refers to the very high frequency 5G spectrum. 5G spectrum is also referred to as millimeter wave spectrum, okay. It's a very low frequency, it's a very high frequency, so it gives you higher bandwidth, okay. Millimeter wave spectrum, we'll discuss that. See, it's a comparison between a 4G and 5G, the download speeds, that is 1 Gbps and this is 20 GB, bandwidth 100 megahertz and this is 1000, and see, the latency is the question, I mean the option asked here is latency, but there can be a question formed with the other traits also. For example, there can be a question on download speed, bandwidth, anything. What we use is latency here, 10 and 1. Latency should be as low as possible, then it is new generation. As generations progress, the latency will reduce. The main advantage with 5G is the latency. Since it is having so less latency, it can be used with IoT, Internet of Things. Okay, with high bandwidths, you can operate things over internet. But if there is a latency, high latency, you press the button now, the machine will move after an hour. Okay, so the latency is very high. So for you to operate anything using internet IoT, you need lower latency, so 5G helps. Okay. the carriers, maximum number of carriers also, carrying capacity also increases with 5G. See, this is actually our Insta question, so I picked the explanation from there. You can also read it later. Okay. See, 5G, there can be other questions. 5G, there are different bands, lower band, middle, higher band. There can be question on band itself, not when compared to 4G, but within 5G itself, band comparison can be asked. What is the advantage with the high band spectrum, okay, when compared to mid and lower band? High band actually gives you highest speeds, but the penetration is very less. Suppose you have a high band internet here, you cannot reach that in the other room because it cannot penetrate to the wall. Okay, but here you will get high speed. That is the advantage with, if there is a wall-less, okay, wall-less institution, you get very good speeds and you not worry about the penetration. There you can use it. Okay, so similarly each one has its headaches and positives. So you have to go and read all those because there can be a question there as well. 23rd question. Consider the following statements with reference to the voice over internet protocol. VoIP phones. Anyone use VoIP phones? Most of the IT companies use VoIP phones. They don't go for BSNL, Airtel, all these things. Okay, they just have a broadband connection, proper broadband connection, and they operate over internet. Okay, so it converts a person's voice into digital signal that travels over the internet. True. It allows a person to make a call directly from a computer. True. It does not have the option to speak to more than one person at a time. No, you can conference with many in a VoIP, so it's a wrong option. All VoIP services require an active internet connection. Yes, it is based on internet. Okay, so the answer is only 3 statements. It's an illustration, so how it operates and all. Okay. Next, 24th. Consider the following statements. Storing data about monetary transactions. At the present level of technology, which of the above activities can be carried out by blockchain technology? That is the question. He has given you a couple of options. One, storing data about monetary transactions. Yes. Okay. See, it has one property that is immutable. Blockchain, one property is immutable. Okay, so it maintains the whole chain. You cannot tamper with the ownership. Okay, so who is the previous owner, who is the next owner, who is the owner two or three times back. Okay, all that is there. Okay, you cannot tamper. So that is taken advantage of for recording the monetary transactions. Okay. Next, cryptocurrencies without the approval of central authority. Yes, you don't have a centralized authority. It's a decentralized blockchain. Blockchain based cryptocurrencies are decentralized. You don't have an RBI. Okay, so they are decentralized. Next, track property ownership. Any ownership can be tracked. Okay, how is it changing hands? With each change of hand, it will be recorded. So you can track. Negotiating a contract agreement. See, if a particular, you can predefine terms of a contract, and as and when the predefined terms are agreed upon, it will take it as a contract signed, and it will go on forever like that. Okay. Facilitating modern voting system. Yes. See, the headache with our modern voting system is there is duplicity. Okay, there are many ghost voters or someone who is voting twice or thrice. These things will be eliminated. Each one will be unique, and once you vote, you cannot vote again. Okay, so you can use it for that as well. Illegal drug trade. More than 40% of drug trade is taking place in Bitcoin, it seems. Okay, so yeah, the answer is 1, 2, 3, 4, 5 and 6. Blockchain applications. Blockchain, most of the people blockchain think that you think that blockchain is synonymous with cryptocurrency. It's not like that. Cryptocurrency is just one application. There are a number of applications. Okay, there are a couple of properties. See, I have discussed immutable. Immutable. Any validated records are irreversible and cannot be changed. Okay, so you can maintain land records. You can maintain monetary trail. You can maintain many other things. Okay, using this property of immutability. Okay. Similarly, there are some distributed. The ledgers are distributed. So many people maintain that transaction, details of the transaction, not one single person. Okay. You can tamper my ledger, but you cannot go and tamper everyone's ledger. So it's difficult to hack. It's difficult to hack and tamper with. Okay. Timestamp. Everything will have a timestamp. A transaction happens and the exact time is noted. You cannot go back and change the time and create a fake transaction. Unanimous. Everyone has to vote. Everyone has to say yes, only then the transaction happens. Okay. The tech part, don't worry, but these are the features of the blockchain. Anonymous. No one knows who is what there. Okay. No one, you need not display your identity anywhere. Very secure. Secure because of all these reasons. Okay. Programmable. You can program it to do anything. Smart contracts is an example given there. Voting. Okay. Monetary trails, land records, and number of things. The purpose can be anything, but the bottom can be blockchain. Okay. So these are a couple of other applications in digital currency, how they are using record keeping, security, smart contracts. In recent times, these are the applications that emerged in crypto, in the blockchain. Okay. 25th question. With reference to India's defense, consider the following statements. Which of the above are indigenous made helicopters in India's defense? See, you cannot by heart all the helicopters and etc. etc. The indigenous are few and they are emerging, they are in use. Just know them, rest you can eliminate. Here, what is the indigenous one? Rudra is the indigenous, rest you can eliminate. D, Rudra. There are a couple of other helicopters also, Prachand, Dhruv, okay. And there are a couple of other helicopter names, you have to go and see, okay. Consider the following statements with reference to unmanned aerial vehicles, UAVs, drones. They are in news, they will be asked different applications actually. See, even for in the night sky they are doing lots of designs and all, even applications can be that also. Okay, they are using it to lighten up, they are replacing firecrackers. Okay. So constellation of swarms of drones, they are actually acting as crackers. So there can be a number of such applications for drones. Okay, there can be questions on drone applications. Okay, that is another area, but here it's defense drones. Okay, unmanned aerial vehicles. Okay, the Heron drones are Israel's multi-role, advanced, long-range, medium altitude, long endurance UAVs. Yes, Israel Heron. Okay. Next, Punchy is a zero-length launcher and stealth UAV developed by DRDO. Punchy. Yes, Punchy is developed by DRDO, but it's not stealth. Okay. Stealth and you are not visible. Stealth, you are not visible. It's a tactical. What you do to play stealth is different tech. It's tech part, we don't worry. But normally stealth, they fly very low so that you are not captured by radar and all. But this is not stealth. Okay, this is for a different purpose. Okay. Next, Searcher Mark II is a reconnaissance UAV procured from France. No, Israel. So the answer is one only. Consider the following statements with reference to Vikram-S. This is also a possible area. Recently in Group 1 APPSC it was asked. can be asked in what is a UPSC also. Okay. So Vikram-S, India's first privately developed launch vehicle, made its maiden flight from the country's only spaceport in Sriharikota. True. It was developed by Hyderabad-based Skyroot Aerospace. Yes. Both are true, both 1 and 2. So Vikram-S Rocket is a single-stage suborbital launch vehicle that would carry 3 customer payloads, that carried actually, it's a past. The Vikram-S Rocket is India's first privately developed launch vehicle into space under the Prelims mission. Prelims mission used Vikram-S Rocket. It is developed by Hyderabad-based startup Skyroot Aerospace. It made its maiden flight from spaceport at Sriharikota. The Chennai-based space tech startup Agni Cosmos, there is another private player, Agni Cosmos. It is going to set up its first private vehicle launch pad at Sriharikota. Launch pad is different from spaceport. Okay. First private launch pad is being started by Agni Cosmos. Next, with reference to Iron Dome, consider the following statements. It is an effective truck-towed mobile air defense system developed by Israel. Yes. Iron Dome detects, analyzes and intercepts unmanned aerial vehicles and air-breathing threats. Yes. India recently integrated Iron Dome air defense system as a part of its missile defense. No, it hasn't, but it has plans to, especially in the northwestern front. Okay, northwestern front, it is trying to integrate after watching the effectiveness of Iron Dome in protecting Israel against Palestinians' missiles, Palestinians' rocket launches. More on it. See, this is the illustration, how it operates. It tries to protect a particular terrain. There is a predefined terrain, it has to protect that. So anything, any projectile that is targeted that area, it gives a signal. Okay, the radar system gives a signal, and immediately a counter rocket is fired from the Iron Dome. Okay, it neutralizes. It's a very highly effective system developed by Israel. So more details I have shared, you can go through later. Okay, the tech part. Next, with reference to project 15B and project 17A, consider the following statements. Project 17A was launched by the Indian Navy to construct a series of stealth guided missile frigates. Yes, this is for frigates. Frigates are kind of ships, okay, warships, okay, small sized ships, okay. So 17A is for that. Next, project 15B is the development of next generation stealth guided missile destroyers of the Indian Army, not the Indian Army, Indian Navy. Okay, this is 15B is also for the Indian Navy. Destroyers means it is Navy. Okay, frigates, destroyers, they are all in the Indian Navy. Okay. Next, Surat and Udaigiri are indigenously built frontline warships of the Indian Navy. Yes. So the answer is 1 and 3 only. See the more details. P17A, project 17 Alpha frigates. It is aimed at constructing a series of stealth guided missile frigates. Okay. Next, P15B, latest stealth guided missile destroyers, again for the Indian Navy. Surat and Udaigiri frontline warships launched at Mumbai's Majdong docks. Okay. And LiFi technology. LiFi, light fidelity technology. Okay, it's like our Wi-Fi, but it uses light. Okay, it is a wireless technology that uses the infrared and visible light spectrum. Yes, it uses infrared also. Along with light, it also uses infrared. It provides high-speed data transmission compared to traditional broadband services. Yes, very high speed. Light gives very high speed. Next, it is unidirectional in transmitting data. No, it is bidirectional. You can uplink and downlink, both can be possible. So it's a bidirectional this thing. So what about LiFi? More on LiFi. There can be other ways to ask questions on LiFi. Is it more secure than Wi-Fi or not? Okay. Yes, it is more secure than Wi-Fi because LiFi operates within a closed premises. Okay. It cannot go beyond a premises. Actually, our Wi-Fi leaks beyond our premises. Okay. It causes a threat to our security. But LiFi has that advantage because wherever the light cannot pass, it won't go there. Okay. Similarly, there are a couple of other things. This is a comparison. So, any of these options can be used to give a twisted question. Okay. So, you have to be thorough with all these things. This I will share with you, you can watch later. This can be zoomed actually, it will be much clearer if you can zoom. So the applications, the technology, is there any interference? Okay. Wi-Fi has interference. Okay. Electromagnetic interference. Okay. But LiFi won't have electromagnetic interference. Okay. Things like that. Okay. You have so there are other things you can watch. Okay. Next, with reference to surveillance devices, consider the following statements. See, LiDAR, radar, sonar, these are all surveillance devices used for different applications and different mediums, okay, and different purposes. So it's a question based on that. LiDAR is a tool to measure the shape and contour of the ground from the air. Yes, they use light, so it is called light, LiDAR. Okay. Radar covers shorter distance when compared to LiDAR devices. No, radar actually covers longer distance because the wavelength is high. Okay, radio waves have a higher wavelength, so they cover higher distance when compared to a light based thing. Next, sonar system is used for measuring the depth of water. Yes, sonar uses the echo. In the water, sonar is better when compared to LiDAR and other techs because electromagnetic, the water, it gets heated because of the electromagnetic waves, it slows down, and by that what happens is the reach will reduce, to extent which the light can reach will be reduced. So sound waves are instead preferred, sonar. Okay. This is because EM waves lose energy. Okay. Next, light waves travel farther in the water than radar and sound waves. No, we have just discussed sound waves actually, especially in water, sound waves travel in the longer distances. So the answer is 1 and 3. A. More. LiDAR, light detection and ranging. Okay, it uses light. Radar, both are of similar tech, but radar uses radio waves. Okay. LiDAR is used for light pulses will be emanating, and they will be recaptured again to see what the three-dimensional characteristics of the surface. Okay. Similarly, radar, it also uses reflection. Then sonar is for underwater this thing. Next. (30)second. See, this in defense there are few areas which are emerging. This is also one. Okay, this is ballistic defense. Okay, if someone shoots a projectile from Pakistan or China, how will you automatically protect yourself? So India have been inventing things on that. Indian Ballistical Missile Defense Program. There is something called Indian Ballistical Missile Defense Program, and within that this is a subtype. Pruthvi defense. Pruthvi defense system is a subtype of that. This operates in atmospheric level and another operates in subatmospheric level. There are two different subsystems of Indian Ballistic Missile Defense Program. Okay. So this is a question on that. With reference to Pruthvi defense vehicle missile, consider the following statements. It is an exo-atmospheric anti-ballistic missile. Yes, it's exo-atmospheric. Out of atmosphere operate chestadi. Okay, so exo-atmospheric. Anti-ballistic. Ballistic and cruise, there are actually thought of discussing them in the latter question on Brahmos, but ballistic endante, see, in a ballistic missile the projectile is once it is shot, the contour of the projectile, I mean the path traced by the projectile cannot be altered. Okay, so ballistic missiles can be countered with counter ballistic missile. If you trace similarly opposite one, you will hit it midway. Okay, but a cruise missile is difficult to counter because cruise missile has onboard systems which can actually change the path. Okay, midway of the cruise missile can change its path. So that is the main difference, and also the speeds and etc. Okay, yes, Mansa. Yeah, anti-ballistic means when a ballistic missile is coming, it is hitting it back. It's an anti-ballistic missile. This is defense actually, air defense. Anti-cruise missile means it will hit a cruise missile. It will neutralize a cruise missile. Ballistic missile means it will anti-ballistic means it will neutralize a ballistic missile. Okay.
So every ballistic missile can also be used as anti-ballistic.
Yeah. Yeah. You trace the possible trajectory where it hits and you use the same similar trajectory path to hit it in the midway. Okay, so that is called anti-ballistic missile. See, this is the path. Okay, once you fire it here, this is the path. What you do is you launch something which will hit it here on midway. Okay, so that is anti-ballistic missile. Okay, so that it doesn't hit your terrain. Okay. Next, it is a 3-stage missile with solid propellant in the first 2 stages and liquid propellant in the 3rd stage. No, it is a 2-stage. Okay. Next, it has been developed indigenously by DRDO. True. So answer is 1 and 3. C. See, other than this, there is also another system, advanced air defense. Okay, that is subatmospheric. Okay, this is in the atmosphere and that is subatmosphere. Anything that is, any missile that is traveling in the atmosphere and the higher altitudes is neutralized by Pruthvi. Okay, but anything which is in the subatmospheric layer, it is neutralized by advanced air defense system. Okay, so it's a combination. Indian ballistic missile defense system is a combination of Pruthvi and AAD. Okay. Next, Agni V. With reference to Agni V, consider the following statements. It is a surface to air ballistic missile. No, surface to surface. It uses a 3-stage solid fueled engine. 3-stage solid fueled engine. Yes. It is capable of striking targets at ranges above 5000 kilometers with very high degree of accuracy. Yes, Agni V. V stands for kind of 5000 kilometers. Okay. So the answer is 2 and 3. What is ICBM? Intercontinental ballistic missile. Once a missile is shot, its trajectory cannot be altered, but it has fuel enough to take it to another continent. Okay. Next, see Agni 5, the stats part of it, okay, the data part of it. Agni has evolved, Agni 1, Agni 2, Agni 3, Agni 4, each one has a different range. Okay, Agni 5 can hit most of the territories in China and all. Okay, so it can be nuclear armed. All missiles are not nuclear capable. Okay, but this is nuclear. It can be nuclear tipped. Okay, surface to surface. Next, consider the following statements with reference to the hypersonic missile. India joined the hypersonic missile club with the launch of Brahmos cruise missile. No, Brahmos is a supersonic cruise missile. Okay, we don't have hypersonic yet. Okay, so that is false. Hypersonic missile Kinzhal or Dagger is developed by China. No, it is a Russian weapon. Unlike other cruise missiles, hypersonic missiles cannot be maneuvered to the intended target. No, they can be maneuvered. All cruise missiles can be maneuvered. Hypersonic cruise missiles can be maneuvered. So the answer is not correct. So answer is D. Answer is D. Cruise missiles can be maneuvered because they have active propulsion elements on board which can change the path, the trajectory. Okay. Next, 35th. Which of the following statements either are correct about non-fungible tokens? It is a digital asset that exists on a blockchain. Non-fungible tokens exist on the blockchain, yes. It is again a application of blockchain technology. We have discussed there are a couple of applications. One application is NFTs of blockchain. Each NFT has a unique digital signature. Yes. This is just to stop fakes. There is this picture of an ape taking a picture of itself. Okay, it is a very popular pic. The ape itself has clicked it. Okay, has taken the picture. That's the one unique picture. There may be a number of copies of that, but that first copy can digitally marketed, digitally be sold, and it will be unique forever. Okay. It can also be used to represent people's identities, property rights, and more. Yes, there are a number of things that can be sold using an NFT. We'll see that. See, this exists on a blockchain. The base is a blockchain. It is used to verify the assets authenticity and ownership. Okay. A number of objects can be converted into NFTs. It can be images, videos, music, text, even tweets. First tweet of a celebrity can be sold. Okay, using NFTs. All these things. So this is NFT. Okay. Next. OpenForge is government. This is current affairs. OpenForge is Government of India's platform for open collaborative development of e-governance applications. True. Niti Aayog is nodal agency for this project. No, MeitY. MeitY is the nodal agency. So answer one only. Electronics and Information Technology. Okay. Next, which of the following frequency spectrum either are used for cellular communication networks? See, these are application everyday observation kind of questions. These also can be asked. Sometimes UPSC asks these questions. Okay, so you have to know, because constantly it is in news that government is selling spectrum. Okay, what spectrum is it selling? What is this reusable spectrum? Okay, what is the spectrum used by defense? What is the spectrum used by civilians? All these are possible questions. So you have to be careful. Here the answer is 1, 2 and 3, all 3. So commonly used bands are 800, 900, 1800, 2100 and 2300. Previously Wi-Fi used to be 2400 megahertz. Now they are using 5 gigahertz. Okay. Bluetooth and Wi-Fi. Next. Which of the following missions aim at exploring an asteroid? This is recently in news actually. A particular mission is being sent to asteroid and another mission is returning from asteroid back to Earth. Okay, NASA's mission. Okay, the Osiris Rex mission. Okay, it has been sent to an asteroid and it has picked samples from there and it is returning back to Earth. Okay, that is asteroid Bennu. Okay, it is soon going to drop its things it picked into the ocean from where it is going to be picked for analysis. So that one. Next, Psyche mission. Psyche is an asteroid, that is a future mission of NASA in the future, not now. Next, JUICE mission is actually European Space Agency's mission to Jupiter's moons, icy moons of Jupiter. Okay. So, the answer is 1 and 2, A. This one is picked from our Insta again. Recently, construction work began on the world's largest radio telescope, the Square Kilometre Array. In this context, consider the following statements about radio telescopes. See, the tech part can always be asked. For example, the Mercury-based telescope we have seen, okay, Hubble telescope, n number of telescopes, even where are they placed, what is the tech, are they using radio waves, are they using reflective technology, all these things are important and UPSC can ask questions on that. Okay. Concept level questions you can always expect from UPSC. Okay. Here, unlike optical telescopes, they can be used in the daytime as well as in the night and are unaffected by interstellar dust clouds. Yes, dust clouds can stop light from coming or it can dim light, but it cannot stop radio waves. Okay. So, that is an advantage over optical telescopes. Okay. Next, they require very large antennas which may be used singly or linked together electronically in an array. Yes. Radio waves are actually heavenly bodies, radio waves coming from there are very weak signals. For that they actually go for huge antennas, huge this thing in arrays actually, not one, just one but many. We will see why they use many. Next, they have much higher resolution than a similarly sized optical telescope. Actually, optical telescopes resolution is better, okay, but they get the same resolution or better resolution in radio telescopes by using array of radio telescopes, so that they give the higher clarity. Just one cannot give you a good clarity like an optical telescope. Okay. So, this is false. The answer is A, 1 and 2. See, this is an example. See how many different, in the left you have a zoomed photo and in the right you have a bird's eye view. Okay. So, this is how cluster of radio antennas, telescopes, they together capture the image. So, statement 3 is incorrect, 1 and 2 we have discussed. 3 is incorrect because they use interferometry to get a precise image, crisp, sharp image. Interferometry is kind of which sharpens the image using n number of inputs from different signals from different radio telescopes. Okay. Okay, last one. Which of the following is not an application of artificial intelligence? Computer vision, yes. Natural language processing, yes. Database management systems, DBS, no. DBS, it's not. You know any DBS systems? Name some. SQL, PLSQL, TSQL, a number of things are there. Okay. And there are different databases, cloud database, Amazon's there is a cloud, Microsoft there is a cloud. A number of clouds are there, but they are not AI based. Okay. Digital assistants, yes. So, the answer is C. Yeah. This is the slide, answer is C. Okay. Yeah, we are done. Thank you.